Hey folks, welcome to this video. This is going to be a developer blog type video. Um, I would just first want to apologize to everybody else on the channel that has been expecting more, Transcription Tuesday type stuff or Finger Buster Friday, all that kind of stuff. For the past month and a half, 2 months, I've been in programmer mode. So that's what's going to be happening in this video. When I'm all done with Cordy and whatnot, I'll get back into that project, and you guys will see a ton of new content from me in that regard. All right, without further ado, this is going to be a developer blog, like I said. I'm going to talk about serialization. So for me, serialization is when I have some data structure that I want to store on disk and be able to load it back into memory and unload it back into memory. So the prime example of this are plugin presets. Say you've got an EQ plugin and you want to store different EQ settings that users can load and whatnot, or if a user wants to save their settings. So this is a good example for how that can get used. So one thing that I've done to kind of make these sort of little projects kind of easy to test around and play with a little bit is to use source control and have just a little project called Sandbox, which is basically my Juice blank template project. Like here, I'll run this just to show you what this looks like. You'll see it's just the generic Hello World application. It doesn't look like anything. And so what I like to do is I'll just make a new branch. In this case, it's called Serializer Demo, like that. All right. And now, like, if I ever want to make a new a new demo or whatever, or just test out some idea or whatever, I can just go back to the master branch, check it out, and then I've got a new clean slate to work from. I can add new source files to and all that kind of stuff. And it doesn't do anything to my boring Juice component, and I just have this little sandbox that I can kind of develop code in and just test out ideas in. And it makes life pretty easy. All right, so let's talk about serialization. So as I said earlier, it's the idea of you have some data that you want to be able to load and restore, such as a user preset. So let's pretend we have an EQ band, or we have an EQ plugin, and the EQ itself has, say it's got a couple frequency bands, and we want to be able to store one of these. We want to be able to store this data as data on disk. So we'll say there's a structure that we use to hold the EQ settings called EQ band, like this. Now, typically an EQ is going to have, it's going to have a gain. No, it's going to have a frequency, right? It's usually going to be an integer because we're not going to do 280.625 hertz or whatever. It's going to be like just 280 hertz. All right, it's going to have a gain value that's going to be a float because we can do like 2.5 dB of gain or negative 3.46 dB of gain, something like that. It's going to have a Q value or bandwidth, so that's also going to be a float, like that. Now EQs have different types, so let's add some different types. We'll do this enum class EQ type. I'm only going to give it a couple types, like this. We'll just do high pass, low, capital L, low pass, and we'll do a bell. All right, bell curve. Okay, cool. So that means this guy has this has an EQ type. Type like that. All right, cool. So now for our serialization, what we want to do, I'm just going to bump this font up just one more time, so it's just a couple more times, so it's just easier to read for anybody that's on a small device like a tablet or whatever. All right, so what we're going to do regarding this serialization is we're going to use the var class in Juice. That's going to be this Juice var, like that. Variant class that can be used to hold a range of primitive values. So all of these are primitives except for EQ type, and we'll get into how to deal with that issue in just a minute. So this is going to be a static method. So to turn it into our variable structure, we're going to go static var is the return type, serializer, like that. And it's going to take an EQ band, a reference to an EQ band, like that. Now it's const because we're not going to modify this at all. We're not going to change any of these values. So that's why it's constant. It's a reference because we don't want to, have an internal copy. Now we want to be able to deserialize it and get back an EQ band when we pass in one of these. All right, so the sister method will be EQ band deserializer, and this is going to take reference to var like that. All right, awesome. Let's begin. Over here is where we will implement this. So what we want to get back is some data structure that looks like this. We want to see, this is kind of what the JSON is going to look like. You'll pardon the missing indentation. Frequency was an integer, so we'll say this is like, 450, or we'll do 440 for A. Our gain is going to be a float, so we'll say that's 2.5. That's going to be like that. Our bandwidth, let's say that's going to be like 1.9. And our type, let's say it's going to be Bell. Okay. We'll say it's something like that. This will probably be a string. Okay. All right. So this is kind of the data that we want to get back. Oops, all these need commas after them. All right. So now we know what we're kind of looking for. We can figure out how to make that happen. All right. So first, let's write our serializer. Static var. Oh, it doesn't need the static keyword. Var EQ band serializer. All right, now we just need to read through each of these properties and use a little helper thing, a little helper piece of code to add it to our var object. So let me pull that up real quick here. All right, so here is our little helper function. This comes from Paul Nayrink on the Juice forum. He shared this little helper function with regard to converting adding objects to var structures. Paul Nayrink is the guy that wrote vControl, I believe. If you've ever seen that iPad software that lets you control all the DAWs from your iPad remotely, it was like one of the first things before all the DAW manufacturers started writing their own apps for their DAWs and whatnot to control them from a device like an iPad or iPhone or something. All right, here we go. Here's our little helper. Auto JSON helper equals, we're going to use a lambda. All right, so first thing is our object that we're going to stuff our data into. The next thing is the key we're going to use to identify it. And then the last thing is the value itself. That's going to get stored in this. All right. Semicolon because it's a lambda. If object.is object. All right. Now we know we can do stuff with it. So object get dynamic object set property. Property name is key and the value is value. All right. That should make a lot of sense if you're familiar with what's going on. We're just kind of setting key value pairs. Now, obviously, as you can see that this says get dynamic object, that means that our JSON needs to be a dynamic object. That's the internal structure that needs to happen. Okay, so now we can just kind of walk through each of these and make it happen. So what I like to do is when I have to write a serializer like this, I'll copy the original properties, comment them out, and then for each one I will just use this helper and fill in the properties. So here we go, JSON helper. Our object is JSON. The key is going to be frequency, and our property is going to be band.frequency, like that. All right, nice and easy. Let's do it for the rest of them. Okay, rad. All right, this is what the other three look like. Now for the EQ type, you'll notice that this isn't a string or anything. It derives from a class. It's going to reduce down to an integer, but that's kind of ugly. We don't really want to see like EQ type 0, EQ 1, EQ type 2. We want to see it say high pass, low pass, and bell. So something we can do is this. If we make a map, include map, then we can provide a map that gives us strings for these. So we go Extern const std map EQ type. It returns a string. EQ type string map. All right, we can just implement that over here. You'll see what we get. All right, and then for each of these, we just make a pair like this. We make a pair that's got EQ type on one side, and then on the other side, it's got the actual thing we wanted to say. So I pass, like that. Okay, I'll fill in the rest. All right, this is what the rest of them look like, nice and easy. If we ever want to add any more types, it's easy to add them. Just add an entry here, then add an entry here. All right, cool. So let's fill in this EQ type. So what we need to do is go JSON helper. And we want to do type. And then we're going to do EQ type string map dot at. And we want band dot type, like that. And what that's going to do is it's going to read the type. It's going to look in this map for the matching type, and it's going to return the string, and then that's going to be passed in for the type. All right, nice and easy. Okay, so let's return that. Return JSON. Now, just to make sure, we're just going to debug it. We're going to go JSON to string. So we'll just make sure that that's what we get. All right, this is the way we can see down here in the console. All right, let's make an EQ band. EQ band. All right, we'll just populate it. All right, cool. Now we can do EQ band serializer band, like that. And we'll put a breakpoint here. We're not going to capture the output yet because I'm not ready to show you the deserializer method. This is mainly just to get this to show up. Actually, just put the breakpoint right there. All right, let's run it and see what we get. All right, awesome. This is a little weird, but that's all right. I guess that's just the internal representation of 1.9. Oh, it's because I didn't do that. These are floats, so they need to be that. Let's check it one more time. All right, still doing that. Well, whatever. That's all right. That'll get reduced down. Okay, cool. All right, let's write our deserializer. Okay. First let's capture the output. Let's just see. What are we going to call this? We'll just call this an auto JSON equals that, like that. All right. Now it's captured. Now we can pump it back in to our deserializer once we write it. Let's write this deserializer. Okay, so EQ band deserializer. Now again, this is the return type. This is the full name of it. You know, here's the namespace, or yeah, here's the namespace qualifier. In our case, it's a struct, and then here's the actual method name. That's why it comes. That's why we got to write it like this, even though it kind of looks like we got EQ band written twice, whatnot. That's just the way C++ works. All right. So first thing we need to do is figure out if this is a dynamic, if it's an object. So if JSON dot is object. We can do auto. Actually, I'm going to change this to be input. Okay. Wait, no, I can leave that as JSON, because that makes sense to me. If auto, okay, we need to get the dynamic object, because you remember that's the internal, that's what we used internally to store all the data. Auto dyno equals JSON.get dynamic object. Okay. Now something else we can do. We can actually skip this step and take this. First of all, this is a pointer. We can take this, put it right here instead. And this way, if this dyno is not a null pointer, then anything in between these two brackets is going to work. So we're going to need to go We can, first let's make our EQ band. All right, that's what's going to get returned. Return band. All right. We need to go, we need to start populating properties. So band dot, let's start with our frequency, equals dyno, get property, and that was frequency. All right. I'm going to fill in the rest just to show you what it looks like, and then I'm going to talk about something that we definitely need to address with regard to this. Okay. All right, we got the got most of them entered in. We need to do our EQ type. Now, one of the problems with STD map is that we can only pass in an EQ type and get our string out of it. So we need to make another map. Ooh, extern const STD map. It goes the other way. String EQ type. EQ type string. Oop. Other way around. String EQ type map. Let's make that a little more clear. EQ type to string map and string to EQ type map. All right. Type to string. EQ type to string. Okay, we'll go the other way right here. Okay, that was nice and easy. All right. Just got to make sure that we're passing in the correct terms. All right. So we're back here for this. So we need to go EQ type. Oops, sorry. Band type equals. Now first we got to get the string itself from the JSON. Dyno get property. We want type. All right, and then we want to get back this value. So we need to pass it into this map. So we can go string to EQ type map dot at, like that. All right. Give that a little bit of room so we can see what it's doing. All right, now we're going to run it. Let me set this up so it actually goes into it. Okay. EQ band deserializer. JSON. I got a breakpoint right here, so we'll be able to inspect the values and make sure that they match these values. All right, let's do it. All right, let's see what we get. Okay, band is 35, gain is 4.5, type is bell. This is almost 1.9F. Very close, 8999998. All right, cool. All right, so the last thing, something we should add is just a way to compare to make sure it works. To make sure our input can be serialized and then deserialized and get the same output. So we need to have a free operator comparison going on. All right, so it's going to be bool operator. This is the operator we're going to overload. Const EQ band on the left-hand side, and another one on the right. Oops, band. Like that. All right, let's implement that. Return left-hand side dot frequency equals right-hand side dot frequency, and left-hand side dot gain. You see where I'm going with this. I'm going to pause this right here. All right, cool. This is what it looks like if left-hand side frequency matches right-hand side frequency. Left-hand gain, right-hand bandwidth, right-hand bandwidth, left-hand type, right-hand type. Now, as we already saw, this is this equals this. It doesn't equal that other value that we saw in right here. So this may fail, but that's all right. That's just something that happens when you deal with floats and doubles and whatnot. All right, so let's just make sure. All right, let's capture the output. EQ band 2 equals this, and 2 equals that. All right, if band equals band 2. So when it gets this and it's converting these two types, it's going to look for an operator equals where the left-hand side and the right-hand side are EQ bands. So it's going to find this function, and it's going to call this. That's how operator overloading works. Okay, it's checking the type of this guy and the type of this guy, and looking for a Boolean equals that has an EQ band on one side and an EQ band on the other. All right. Else. All right. If the bands are equal, debug, yay. If they're not, debug, frowny face. All right. Add this right here, and we'll add a breakpoint right there, just in case that's the case, which that might actually be what happens because of this. We'll be able to see that, you know, everything else kind of worked correctly. All right, let's run it and see what we get. All right, look at that. Yay. All right, awesome. Okay, now I said there was one other thing I wanted to talk about, and that was this. Okay, you notice that it's pretty easy to misspell things. Like when I typed this, I typed it with an F by accident. Caught myself. It can be kind of difficult to debug that kind of stuff. If you're not paying attention, like imagine you had a huge struct that had like, you know, a bunch of methods and a bunch of different sub-objects. So something you can do, and this can help when you get some really big objects. A lot of people might think that this is a little bit overkill, but what you can do is you can do enum class EQ band members, like that, and then you can just give each thing its own name, frequency, gain, bandwidth, type, like that. All right, and then you add a map, extern const std map, EQ band members, string, EQ band members to string map. Fill it in. All right. Now what you can do, let me move this over, make it look a little nicer. Oh, this also needs EQ band members in front. Two quotes indicating namespace. All right. Everything turns green. We know it's okay. Well, one of them did. All right. So now what we can do, instead of typing this, we can do EQ band members dot at EQ band members frequency. All right, we can do that for all of these. Now there's no question as to what string we wanted to store it with. EQ band members dot at EQ. Oh, this is the wrong thing. Oh, we want this map. You notice that things are starting to get a little crowded, so we'll clean it up. We'll make it look like this. It's a little bit nicer. Okay, cool. Now, do the same thing right here. Dot get property EQ band at. Okay, we wanted frequency. EQ band members frequency. Give this a little bit of room. Same thing here. EQ band members dot at. I'm missing a closed parentheses. There you go. Awesome. All right. This should still give us a yay. Let's check it out. Sure enough, yay. So even though this looks more complicated, the beauty of it is that there's no issue of us mistyping this. And then whenever we're actually looking for things, like say we're not sure what we want to go here, we can do like that, press escape, and we can see exactly what our choices are. All right, we know we want frequency. All right, awesome. Now, now let's pretend, just to extend on this, let's pretend that our EQ has 3 different bands, okay? So we already wrote a method that will serialize one band, but let's say we have a struct over here, struct EQ, and it's got 3 bands in it. All right, so EQ band, the A band, all right, EQ band, B band, EQ band, C band. Okay, so obviously we need to write a bool operator that's going to search for that. So bool operator, okay, it's got const EQ on the left-hand side and a const EQ on the right-hand side. All right, we'll implement that in a minute. Okay, we'll implement that right now. All right, left-hand side dot A equal, oops, sorry, return left-hand side dot A equals right-hand side dot A, and left-hand side dot B equals right-hand side dot B, and left-hand side dot C equals right-hand side dot C. What's cool about this is, if you remember from earlier, this Boolean statement right here, with the double equals, so A is an EQ band, so it sees that there's on one side of this comparison, it's going to see that one side is an EQ band and the other side is also an EQ band. So it's going to call this operator. All right, that's how that's going to work. It's pretty fancy. We'll do that. Okay. So we need to add a serializer for this and a deserializer for that. So we'll just copy this. All right. EQ. And you get back EQ. Okay. Like that. All right, awesome. Let's get to work on that. All right, we got our little framework in here. Before we do that, I just want to show what it looks like. I'm just going to change the way these are constructed because this is going to take up a lot of space. So what we can do, we can write it like this. First of all, let me get rid of this stuff here. Okay. We're going to write it like this. Okay, the way we're going to write it is just using this like default constructor type method. So the way this is going to work is our EQ is going to take 3 different EQ bands like this. We'll go EQ, here's our constructor, const EQ band A, const EQ band B, const EQ band C. All right. If you've never seen these, let me change this view a little bit, make it a little bit easier to see this. These look like this. So capital A, initialize the member with the parameter, initialize C with input, and that's that. Now we're going to need one of these for EQ band as well. So EQ band is going to be int F, float G, float bandwidth, EQ type T. All right. Same thing here. Frequency, gain, G, bandwidth, B, and type T, like that. All right. We're just initializing the members. So what happens is, we're just initializing the members based on the input from here. Nice and easy. Okay, switch back to our big view. Okay, so what happens here is when it sees this constructor, it looks for this constructor here. And then it just, it looks for this constructor here. Make this a little easier to read. Same thing here. We'll make this just a little bit easier to read. Give ourselves a little bit more room. Okay, so we just need to create our EQ band. So the first one, let's say this has a frequency of 250. It's got a bandwidth, frequency of this, it's got a gain of, let's say, 4, bandwidth of 2.5. All right, so this is what we got. We got our high pass at 250. We got a bell curve at 1500 hertz. We got a low pass at 75, which doesn't make sense because it's got gain. This should probably be like high shelf and low shelf or whatever, or low shelf, high shelf. Anyway, it doesn't matter, you know, for the purposes of this example and for this little developer blog tutorial thing. All right, let's look at our deserializer. Okay, so the good thing about this is we're going to get to use this, not this, we're going to get to use this serializer here to serialize each element. So we got var a band, all right, equals, okay, we're going to call our EQ band serializer. EQ band serializer. We got EQ dot A. All right. Var B band equals same thing. EQ band serializer EQ dot B. All right. And finally var C band whoop equals EQ band serializer EQ dot C. Okay. Now we need to combine this into an object. So we'll do the same thing where we made a dynamic object. We'll use our same JSON helper. And I'm actually going to make this a free function now. All right, we'll just put this up here at the top. This returns a var, JSON helper. All right, copy this. And we'll implement that right here. Var JSON helper. So we can just copy this. Paste it right here. All right, we can get rid of you. Okay. So now we can just call that JSON helper directly. All right, so we just need to make our new JSON object. So var JSON new dynamic object. All right. JSON is what we're going to return, so return JSON. Now we just fill in the, we just use JSON helper. Our object is JSON. Whoops. Our string is going to be A band, and our value is A band. Right, repeat for the other two. JSON, C band, whoops, type it faster than I can, C band. All right, awesome. Okay, that's gonna spit out everything we need, the way we need it. And just to double check it, let me get rid of this guy, or let me just move this guy here. So let's run that and see what we get. EQ serializer EQ. Okay, we are serializing the object we just created here. Let's see what this looks like. I got my breakpoint right after this. Here we go. Oh, got some errors. All right, so it turns out we just have to add this EQ band right here. And that also means, for whatever reason, and I'm not totally sure about this, we don't need to use this constructor. And actually what I think that means is just to, let me just see if my suspicions are correct. If we uncomment that, and we actually make this have parentheses around it. Let's see if that's the case. All right, we'll run it. See if we get that same error. Oh, yeah, we do. Okay, so we'll just leave that the way it was. Okay, float. I'm not sure why that was doing that. Anyway, we'll get rid of that. All right, and it works now. And we run it. Okay, our breakpoint gets hit. Let's see what this debug output looks like. All right. 254, 2.5, high pass, awesome. 1500, -3, kind of 1.8, bell, 75. All right, awesome. So our serializer totally worked. All right, let's deserialize it. Var JSON equal, yeah. All right. Var, I'm sorry, EQ2 equals EQ deserializer JSON. All right, we haven't written this, so let's put that together now. Okay, we got this coded up. Let's take a look at what's going on. So obviously our return type is an EQ, so we need to create an EQ that we're going to return. Now, we need to have, the first time we wrote the EQ structure, it required 3 different EQ bands to be passed in as the parameters. So we needed to create an instance where it doesn't take any any parameters in order for this usage to happen here. Okay, so we had to write this little default constructor. Okay, so then the next thing we do is first we got to pull our A band property that we created here. We got to pull that from our dynamic object from here. All right, and then we need to run it through the EQ band deserializer, which we wrote here. Okay, and we do that for all 3 bands like this. Get band A, get band B, get band C. All right, and then now we can say EQ equals, and this is just another way I could have written. This is just another way I could have written EQ, EQ, A band, B band, C band, right? Just, basically calling this constructor and then assigning it to our object here. This is just like a simpler way. That's what this does with these 3 things in that syntax. It calls this constructor, creates an anonymous one, and then assigns it to our EQ, and then returns it. And then finally we can check, capture the output of it, compare it if it's equal. If you remember, if we have an EQ on the left-hand side and an EQ on the right-hand side, it's going to call this operator that's been overloaded. And then that internally is going to compare if we have an EQ on either side, EQ band on either side. We got A right here. This A is an EQ band. So that calls this operator. All right. So let's see what we get. If they're equal, then yay. And don't look down here, even though you saw there was already a yay. Let's just run it just to see. Okay. And yay. All right, so there you go. There's obviously some other things we could have done. We could have implemented our whole EQ band members to string map thing, like EQ band types to string, to kind of make this a little bit less prone from typing errors. But, other than that, that's basically how to write a serializer and deserializer for data structures. That would be these structures right here. Okay. I hope you dug that. I hope you got some out of it. Obviously, more things you could do. Write some functions that save it and load it to disk, but the general concept is pretty easy. That wasn't that difficult to write. A lot of it is just knowing the framework and then knowing how to write utility functions. Oh, I forgot to mention that I moved the JSON helper into its own standalone function so I could use it outside of the serializer because I needed to use it here. All right. Anyway, I hope you enjoyed that. Hope you got a lot out of it. Good luck with your own projects, and if you have any questions about this, feel free to hit me up and shoot me a message. Leave me a like, leave me a subscribe. I like doing these programming tutorials. I just like teaching in general. Not in a classroom setting, but just like a one-on-one tutorial kind of thing. All right, take care. Peace.